Hi, Doug here. So I've been piecing together this project for quite a while. Some time ago, I was able to acquire a bunch of pieces to a very high power microscope, which I'll be going through today. The reason we're starting with some pictures is I kind of wasn't really anticipating doing a whole video on this, so I never really did an intro video when I started getting the parts. So here you can see some of the parts, the lamp module on the left and the top panel on the right. Everything was filthy. It like sat in like a garage or a shop for a long time. It just corrosion on stuff. It's just been sitting. Again, I got it because it wasn't working, so I got a steal of a deal on it, basically scrap price. And at 700 pounds, it was still a good deal. But I just wanted to show some pictures of where it kind of started. I've been meticulously over many years now cleaning up pieces, refining them, and I finally got everything I needed to put it all together. So that's why I'm putting this video together today. So without further ado, let's move on to the next steps. Here's the fancy foot platform. It has these precision machined insets that the legs of each part goes into. And then this is the adjustable feet with a really fine set screw on it. You put a little wrench in there and you can adjust them to perfectly level out the platform. But that's what the scope goes in the front here, and the illuminator module goes in the back, and it locks the two together so optically the path remains aligned. And these are solid steel. They're quite heavy, quite awesome. So here's the lamp assembly. Take off the cover here. Here's the inside. I've been slowly trying to clean up the optics, but this is the reason I got it so cheap. The mirror was cracked. I'll post a picture up here in the video. I shoved it back together as best I can. It's a plate of pure silver, and if it rotates around like so, reflective underneath as well. There's more optics down below. So this particular scope has an output for here, for above and below, or you can do both for doing dark field. And a little thing up here lets you know A and D for up and down. It's a German scope. And you could select which lamp. So each one of these is a lamp housing. You can hold up to 3. This one was for a metal halide, which I didn't get that bulb sadly with it, so it doesn't work. This one has a little projector incandescent bulb in it. And on the back here, you release the little housing, and this slides out. I mentioned this is from the 70s. It's also a precision instrument that I need to be gentle with. There we go. So on the back here, you can see those knobs. Those knobs are used for adjusting the X and Y of the culminating mirror back there, and for adjusting the lens at the front. The goal of that is you want the output or the filament to be perfectly centered inside that housing. And the way you do that is up top here is a little sight glass. If you look in here, you can see. So whenever you have this pointed at your particular optic or the lamp you're using, the light will come up, go through that. Part of it will come up to here, and this is where you dial in those set screws to get the light perfectly centered so it comes out perfectly culminated through this to the optics inside the microscope. So this giant cast piece, which is about 45 pounds, just held the 3 lamps. So because I don't have the halide bulb and I'm probably not using these optics, I got myself a high power LED fixture here that needs to be mounted to a heatsink, and I'm probably just going to replace this entire module with just that and have that go on the inside of the microscope to light it. So I'm going to work on that and see if that works. Might have to get a diffuser, but this is the light generator section of the microscope. Spend some very precarious, delicate time swapping out this mirror, and you may ask yourself, Doug, where did you find a spare mirror for an old telescope or microscope like this? Well, it's amazing what you find if you look around a little hard enough on the internet. So turns out this mirror is actually a solid crystal of lithium phosphor. This one happens to be 4 millimeter thick. It's pretty crazy stuff. Normally, like new, this would be a $350 piece of material for the mirror. They use it because it's optically pure and works really well and has very, very low light absorption. Which works when you have 300 watts of heat going through it. You don't want it to heat up, I guess. Swapping this out was quite an adventure. So originally I thought I would just pull these screws out here. Well, they have some celastic in here holding it in, and they fixed this because it's a calibrated position on how it's mounted. So what I ended up having to do was, from the back side here, I had to swap out these clips, and to hold everything in place, because it's this very delicate crystal, I ended up taking the whole thing, I rotated it like this, and leaned the whole apparatus down on my bench sideways on a diagonal so it could rest naturally in the holster while I put the clips on. Really delicate, dangerous process, because I imagine this is the only one in existence I'd be able to find online. Because again, they only made 600 of these microscopes in existence. So just the odds of finding this is pretty crazy. But got it in. So now the microscope should work as originally intended, which is really exciting. So I'm going to go on to the next step and start putting this back together. So when I got this is the halide, or the 250 watt arc lamp enclosure for the main lamp assembly. It was missing the lamp. It just had this. I was able to source online a replacement lamp. Here's an arc lamp, different manufacturer than normal, but it should match the spec. And it looks like this electrode sits down inside this cavity, and then the little fork connection there goes under this nut here. So this guy's kind of neat. It has a special little lock mechanism that goes to this index pin here and allows you to cock it in, and it lines it up correctly. Now there's multiple screws. So this one here, adjust left to right, swing on it. And then this one up here, adjust how far in or out it goes. So in and or out this direction. And that puts it in the center here. And then the culmination mirror on the back has X and Y settings for dialing that mirror in left to right, up and down, and in and out to get the focus to go through this lens here, which also has its own adjustments on the back. So all of this is used to go through that set eye in there to get everything calibrated so that arc is perfectly centered. So the arc between those two electrodes is perfectly centered to come out the exact center and culminate as a perfect beam coming out of that output to go into the scope. So I'm gonna get this installed, which I'm gonna need 2 hands for, and hopefully it all works out. All right, so what you're looking at here is through the output window. You can see the 2 electrodes there. I'll hold my phone centered. I got them mostly centered up. The lamp itself was missing the lower lamp holder, so it's crude, but I made my own little friction brass insert that grips around the bottom of the positive electrode to hold on, and then the top's got the little clamp there. And then I adjusted all the screws to basically put it in the middle there, and then this little diffuser swings up to allow you to line it up, and that is controlled by this set screw from the outside. So I'm gonna go ahead and get this installed, and then we'll find out if it'll strike once it's all together. Fingers crossed. All right, so we got both lamp modules in. They both have lamps in them. Here's the inside. You can see the crosshair across the top here, which I'm gonna cover with my fingers. That is now optically aligned, and I got the control working for the mirror selector, and it's got the new mirror in it. So this module is all ready to go. I got the inside completely refurbished. The heatsink is completely cleaned out inside, and the selector switch is all cleaned up and new. So now I just gotta put it in the scope and see what happens. So here's the sample stage. This is the lock. So if I undo this lock here, this can slide out. And you see there's multiple levels here that I can slide it in on, and it locks in there. And I tighten that down like so, and it precisely locks it perfectly level to the platform. These little guys here allow me to do the X movement, the Y movement, and then the larger disc here I can rotate among the center axis, so I can do diagonal moves with it, which is really cool. And this allows you to lock the tension of the indent, and this one allows you to lock the disc itself so it can't rotate. And like I said, these are modules, so these are your guide pins that go in each module, and then the top piece, which I have sitting here, will slide down onto that, and then locking bolts hold it all together. So this microscope could be set up for dual field. So down below you see the hole down to the table. That allows for light to come up from the bottom, which this scope didn't have that feature installed. All right, so I have the optical stage on top of the sliding platform now, and I got this cover removed just to get some of the parts inside working again. So I'm gonna set that off to the side. Actually, check out that word at the bottom there. I'm gonna let you try to pronounce that. And I like how it's also Zeiss West Germany. I believe this thing was built late 70s, early 80s, best I can tell. But man, is it solid. All the parts together were close to 700 pounds on the pallet. So she's a beast. Really thick steel. When you have an optical system that relies on optical paths between modules, it needs to be rigid, solid, and heavy, just absorb mass and vibration. Or vibration through mass. So this thing is ridiculously heavy. And I only have 2 modules together so far. But I wanted to show you in the back here, this is where the main light comes in from the light module I just showed you. And then this box here is for different light filters. So if I push this one out a little bit, I pull this out. These are all different filters. Diachromatic filters, prisms, light filtering, block IR, pass only IR, pass ultraviolet, remove ultraviolet. So those all go through the optical path here into the scope. This guy's really neat. I'm gonna slide this one out. I'll set this guy on top here. So you have a knob here with numbers on it. And as I move that, you notice there's an aperture that gets larger and smaller there. There you go. So that can vary how much light is coming through and what level of culmination it has coming through. And then the one with the circle in the middle, that's for dark field microscopy. That's going to be a whole video for another day, but it works on difference in light to show surface imperfections through diffraction, which is really cool. And then there's just an open path. And that guy lives on the side here, like so. And you select a position through indents on the side here. So that's that one. And then on the top here, you'll see that there's another one inside there. There's a lever on the side that moves that piece in and out. That one took me forever to find. It is that little tiny one there. You stick a finger in and you, I've got big fingers, but you put the finger in and you pull to pull that part out. And then there's another one down here, this one. You can move that in and out, and then the whole module can slide in and out, and you can change the angle of it. I haven't quite figured out what that one is yet. But once I get some light through this, I'll be able to figure out those parts. And then there's another module here that took me a while to figure out where it goes. And this is the same thing. It's another one of those ones that has a little aperture inside. This is for the dark field microscopy. So that goes in a special little slit here in the side, which someone who deals with these for a living is going to be yelling at me for my lack of care with precision instrument here. So these, I think, do the same thing as these two do, but that's for the dark field because you need both light top and bottom to cancel out, so you have to match your settings. So I believe that's what that's all for. And then I got more. So we got these front ones here, and these guys pull in and out, like so. And these are polarizers. So you put your polarizer in, which polarizes the light, and then this puts it in again, but it has a rotatable disc to change the angle of the polarizer, so you can fully cancel the light, partially cancel it, and so forth. So there's so many things you can inject into the optical path to do your different settings. So there's a wire in here, and the only wire pretty much in the whole system goes down into this box. That box has the motor in it for the power focus. Yes, that focus raises and lowers it just like a regular microscope, except this one has a power motor, which I'll cover in a moment, with a joystick that allows you to fine tune and control the focus on this. So this is the primary stage. We're gonna move up to the optical output stage next, which is gonna be really cool. So I got the upper ocular section in where you actually put your eyeballs, the eyeball interface for this. And this is another stupid heavy module. So we'll take the top off on this one. I've removed the screws already. And fun fact, they use a grease on the inside here. If you notice, it collects any dust that makes it into the microscope so it doesn't get into the optics. So instead of trying to make it perfectly sealed, you just put that grease to collect any stray dust. Look at the inside of this thing. It is beautiful. So this guy here is trying to figure out what the short arrow and the long arrow meant. Well, it's because there's two optical points to put your vision, if you will. And if you turn this, it literally rotates a prism to change what direction the binoculars pick up, or the ocular input. So that's pretty cool. This guy here is zoom. And you can see it moves an optic inside here. So let me try to explain what's going on. So if you notice from the other section, light comes up through the middle. So it comes up to the middle to this rotating section here. I currently have it set to left. So what that does is, it's kind of weird, but the light comes in, goes through here, goes to this prism, goes through this lens, goes through this mirror, goes through the zoom array, through this mirror, back through the prism, back to this direction, back into here, and then out to your eyeballs. So if you look in here, I currently have a sample in there. If I can get, yeah, you can kind of tell. So for light right now, I'm using a fiber optic illuminary that I'm literally just shining into the aperture hole in the back. So that was proof of concept that I don't need the big light array on the back, which has the cracked mirror in it, so I can build my own LED input for it, which also makes this like 200 pounds lighter. So I have that part. What's this over here? This is for dark field microscopy. It moves a really cool optic into place when you do that, into the light path, and then you have a focus here and a zoom. That not to get too complicated for this video, but what happens is the light is sent down the top and reflected back through two different polarized paths. So when they hit at the middle, and if it's a perfectly flat surface, they cancel out and you get blackness. But any imperfection in that surface will change the polarization of the light, and you see the difference. So you're seeing the, it's like an interferometry. You're seeing the difference or the interference pattern of the light on the surface to give you very high contrast on very smooth surfaces. So in theory, you could see atomic level stuff through this, which is really cool. I also found out doing some research into this particular one, they only made 600 of these. So they're kind of rare. They were stupid expensive. Back in 1979, this was $100,000, adjusted for inflation, about 350 grand. So no one bought them. So that's the funny part. IBM bought a ton of them, about 250 of them for semiconductor research. So that's kind of cool. Again, there's no market for them right now. They use film, they're old analog systems. So it's kind of cool. But learning a lot about it. This center optical section is pretty well frozen. The grease in it has seized up. So I can move these gears, but it's not moving that section. So I need to get that freed up. And I see some rust here, so I wonder if some moisture got in, which would be kind of a bummer. This section over here also is frozen. I can't get it to rotate, and that changes the light path on where the light moves around inside here as well. So it's kind of cool to see all this parts. On the sides here, you have more modules. This one, you probably won't be able to see it, but there is the world's tiniest text in there that gives you different micron scales. So it's currently set to 25 micron. So I'll link to a picture here so you can see the little micron scale. And then over on this side, this one has different discs that rotate around in it. So this one has like a dot in it. That one has a grid. Oh, it does not want to focus on that. There you go, a little micro grid. And there's the focusing dot. And that one's a crosshair. And then those just live in the little module on the side here, and they get inserted into that optical path that passes around. So if I can get this to rotate, this is the one I want. When that gets spun around to the center section, that does a direct pass through straight up to the camera module, so I can actually take high-res photos of it. So I'm going to try to get to that stage next. But as it is now, it's sitting at like 350 pounds. I can barely move the thing, but it is awesome. So move on to the next stage, get the camera module on there. All right, this took some time. I was able to disassemble just enough without losing synchronicity with the gears and get the old grease freed up so it now operates. So I can now move the optical channels. It is amazing the overkill that is in this system just for driving. I mean, look at this giant hubless bearing here, just for driving these optics. So this path here, it passes from the objective all the way up to the upper camera module, and it also passes over and around and through to the eyepiece. If I move it to this one, it ignores the camera module and just passes it to the ocular piece. And if I move it all the way to this one, this goes straight to the film section, which was sitting on top here. It bypasses this module and goes straight to the camera section, which I'll cover next. Over here, this one was a little harder to get freed up. You can see all the beautiful prisms on that one. This one I'm a little confused about what it does. It takes the path and passes it to the ocular piece, and you can see here straight up or straight through, straight to the inside, and then a combination of both. And the little arrow here indicates what the default setting is. So that's the optical pass module. Again, I got everything freed up, so the zooms, the dark field and light field, all this stuff is fully operational now. So this whole section is fully operational and cleaned. It's been microfibered, so it should be good to go for the next stage. All right, so here is the photography module. This is a really cool module. I wish I could get working. I'll explain what I discovered with it. So over here on the side is where you set your exposure and f-stop. And then in here is where the film goes. So I'm going to try to do this one-handed here. And that has to rotate that way. And that slides out. And then this is the cartridge where the film goes. So it literally works just like a camera. And this one tells you how many pictures you've taken. So that whole module slides into there. And on the front here is where you set all your camera settings. There's an exposure meter. And then here This flap, this one, is for setting Polaroids. Yes, you heard that right. Polaroids. So you load the instant film back behind this little door here. And once you load it in, you pull this flap out to get it ready. And then you press this button here to expose it. Once you're happy with your Polaroid image, you can then press your button here to capture it to film. So I got real excited about this module and hoping that I could use it. And I opened it up. It's a work of art inside, by the way, just like all these modules. But I noticed this connector here wasn't hooked up to anything. So I'm like, all right, well, there's sockets down here. I'll plug it in. Circuit board. And look at the back here, and there's all those connectors. They're covered so they don't have any light leak. Well, there's a connector sticking out the back of this module. This box here, no receiver. It's completely empty. There's no wires in this at all. So apparently this is not original to this scope. So I maybe got a mismatched part. So that's kind of a bummer. It doesn't work. The optics, though, still do. And here's that part I was mentioning about the exposure flapper. So if I take this to this stage here, it'll go straight up to my camera module, and then this will go to the light meter here for exposure, and then this one's for film. So it's a cool little module. It's a bummer I won't be able to get it to work, but it's kind of cool. You can see the light come in from the front there. But yeah, so that's that guy. But it is needed optically, because when I talk about it next, you'll see the light passes up through and goes to a camera I can place on top. So this is needed physically just for the depth of field to work properly with the sensor. So cool piece, but next to move on. The thing about this microscope is modular. So each one of these stages is a module that can be swapped, rearranged, and moved because the optical path runs through the center. So it's flexible. You can even rotate each module to fit wherever you need it to work. What's neat about that is it requires these really awesome precision pieces of hardware that slide down in these indexing holes here. And then basically you put those in. Those get torqued down like so. And then once you have those in place, you can see the dirt on this. Everything on this scope was covered in this film from, I guess, just sitting in a warehouse. Fun stuff. So these are the machined indexing pins. So those get dropped in, and then the next module goes on top. It's indexed and locked perfectly to the optical center of the piece. And you just work around, put all those in, and then you put your next stack on top and keep on going. It's kind of cool. Here's the top of the cake. A solid 1-inch thick piece of steel. Why? Who knows? That goes on the very top of this entire stack here. And the point of this is your camera mount. This is the last output stage of the scope. So this mount goes on here like so. And then this is a CCD camera mount, which was an old analog video mount that I won't be using. I need to adapt that to a camera T mount. So eventually that will mate on like so. Just got to find the adapter. And then I will be able to take my DSLR, and that will mate up on top of there. And I'll be able to get really high-res photos, since obviously it's very hard to get 35mm film anymore. And then these are adorable little, you'll never find these again, last stage bolts that go in here that lock this top stage on to complete the entire assembly. It's pretty darn cool. Like I said, there's the final entry piece with the top on it. It's a pretty awesome piece of hardware. So here is the control box for the scope. This here is for adjusting the focus, the motorized motor we talked about earlier, which is built into this section here. And it's fully proportional on speed, so you can control your focus. This is for deck lighting. There's 2 levels of deck lighting. This is for your primary tungsten lamp for illumination, and this gives you your output voltage for that. This is internal or external control. Haven't quite figured out what that does. There's an A button here. Again, German manual's all in German, so I haven't quite figured out what that does yet either. And this here seems to be an adjustment of the range of how far this moves. But I spent the last couple hours cleaning all these cables. They were black. They're now a nice gray again. The inside of this, though, is gorgeous. Look at that. This is basically what no money object back in the day would get you. It's beautiful. Craftsmanship at its finest. Really nice joystick inside. It's actually a up, down, left, right joystick, and they just have a blocker plate in there for only up, down. So I'm guessing there are other features that different scopes had. The connector on it is an old Siemens connector. Look at that, dual inline connector. You don't see those anymore. Pretty darn cool. Then you just have a standard banana plug that connects it to the power output for the power supply, which I'll get to next. Here's the back of the control box. I wanted to cover this because just this beautiful logo on the back here and all the different connectors. This was the only casualty I noticed on this guy. I got it broken, sadly. It's a little under too much tension to glue it back on, so I'll have to disassemble that someday and rebond that. But it is bonded internally to another strain relief, so I'm not really worried about it. But very cool. These are for features that I guess this scope does not have, these extra ones here. And I'm guessing this CZG was the company who owned this scope before me. Really old asset tag, but very cool. Just wanted to show you the backside of it. So you may be asking yourself, why the change in scenery? Well, this massive, heavy, dense box here is the power supply for that microscope. It has all the connectors for the control box, the power output for the lamps, but not all the lamps. This one only does the incandescent lamp or the tungsten filament lamp. The short arc lamp or the xenon requires a much bigger power supply, which I'll get to next. But this thing's just really heavy. I didn't want to have it up on the bench. So here is the Zeiss power supply, which is pretty darn awesome. All right, so this came along with the scope, and it's for the arc lamp inside. So the lamp I found is a TJS model, and these show HBO or CSI model. So I don't know if this is going to work. This one looks like it had a plus minus on it, so it's DC, where this is listed as AC. Again, I don't know if this is supposed to go with this scope or not, but the connector fit on the back. So it's also missing the top, which tells me it may not be working, but might as well film it, see what happens. So we're going to turn it on. It looks like it's been used for 937 hours. And we're going to try to strike an arc and see what happens. I'm not seeing any current draws. So either that's not the right lamp type, arc gap's too big, or the starter's bad, which I hear the spark gap going back there, so I may have to look into that. But hey, it's worth a shot, see if it would work. But I think this is telling me that if I don't use this 100-pound power supply and that giant lamp, I can convert it all over to LED and get the same effect for a much less power draw. So we'll see how that goes. I spoke too soon. I got some results here. It almost wants to strike. Oh, that sounds solid. Almost. Oh, I think we got something. Now I gotta try to slide this in very carefully and lock it. We're pulling about 4 amps. Doesn't sound the most stable, but we do have light output on the scope. And you probably won't be able to see anything in here. Let's see. There it is. Looks like a ton of UV though, because it's coming across as green in the camera here. Interesting. All right. I'm not gonna run it too long at the moment, but we did get the light to strike, so maybe the power supply is good. Interesting. I'm gonna have to calibrate though, because if I turn this light off, let me look down in here. Actually, it's pretty close to center. You're pretty lucky just eyeballing it there. You can see the light passing through the different innards there. Pretty darn neat. And our current's starting to come down, so we're starting to stabilize. And that is a beautiful white light coming out of that. All right, I'm gonna do some testing for UV before I stick my eyeballs in there to see how it's doing, but arc lamp works. Cool. All right, so it is all assembled. We got first light. You can see the image there on the scope. And I'll take you into one of the eyepieces here, see if this will work with the camera. It kind of works on the phone. So got that working. I got the selector knob in here working, which is nice, which selects if it goes to this image or up to the camera. My camera setup's a little janky at the moment. It's a ProScope HR. It's a handheld microscope that I have attached to this old, 1980s Zeiss camera mount. I'll have to 3D print something for that, but it works. The problem with it is the sensor on this is way too small. This is a little 1/4 inch sensor. This is meant for like a large, full frame sensor. So if you notice, we're getting this scale here that's zoomed in almost 50 times what you get when you look through here. Notice it's only looking at that little small section in the middle there. So yeah, I need to work on that. This I did find out is the zoom, so you can zoom in and out for the eyepiece only. This changes optics left or right, and this is for dark field microscopy, which is a whole video on its own. Have my camera down there I've been playing around with. I got the apertures working, so it's kind of cool. Got all this stuff hooked up. It's fully operational. I can control my tungsten lamp there. I got to build a cover for the halide lamp, and I got to get all the controls and wires run so it's pretty. But she's all set up and running. So thanks for staying along for such a long video. It was pretty cool to make it and pretty cool to see it in the process. Also happy that I could get this thing back to former glory. I don't know if it's all original parts, but it's pretty darn cool to see a completed Axiomat in person. Again, only 600 of these ever made, and the fact that one is sitting here in my family room is pretty awesome. Thanks again for watching.